Hi everyone, welcome back. Today's lecture on 2.2 is about subsets. So if you'll recall from the last lecture, we talked about a set, which is just a collection of elements. So if I thought of this as maybe set A, and in set A, I've got the numbers 1, 2, 3, 4, 5, and I want to pull out just maybe 4 and 5. 4 and 5 would be my subset, so we'll call that B. So here B would be a subset of A. So in this case, that just means that all the elements of set B are also elements of set A. So set A is a subset of set B if and only if. That's what IFF means. All the elements of set A are also elements of set B. Sometimes we like subsets because we like to look at smaller, more manageable sets for various reasons. And as you saw, the symbol for subset looks like a sideways U with a line underneath it. So in the following three examples, we're going to determine whether the following sets A are a subset of B. So what I need to do is look at set A and compare it to set B. And as long as set B has all the elements that A has, then A is a subset. So if I was to look at set A, I've got Brazil, Argentina, and Peru. And if I compare that to set B has the same countries, just an extra one. But that's okay because A is the subset, so it's going to be smaller. So in this case, A is a subset of B. If I look at the next example, set A is 1, 3, 5, and 7, and set B is 1 and 3. So in this case, A is not a subset of B. So I'm going to put the subset symbol with a slash through it. And the reason it's not a subset is because A has two more elements in it, 5 and 7, that B does not. B shares 1 and 3, but it does not share 5 and 7. So to correct this, I could say B is a subset of A. That would be true because A is the larger set, and B, the elements of B are also in A. And in the third example, we've got set builder notation. And remember, this is just read. Set A is all of the elements of X such that X is a yellow fruit. And B are all of the elements of X such that X is a red fruit. So I want to see if all the elements of A are also in B. There are some red fruit that are not also yellow fruit. So A is not a subset of B. Now, subsets are slightly different than proper subsets. A proper subset occurs when all the elements of set A are elements of set B, and set A does not equal set B. So if you'll recall from earlier, we talked about sets being equal in the last lecture. So sets are equal when they have the same elements. So if they're not equal, they don't have the same elements. So what I'm going to do is I'm going to compare the sets and see if they're equal or not equal. And if they're not equal, and as long as all the elements of set A are also elements of set B, then set A would be a proper subset. The symbol for proper subset is the sideways U, but there's no slash or no line underneath it. So if we look at this example, if we consider set A as the three colors red, blue, and yellow, and set B are the colors red, orange, yellow, green, blue, and violet, is set A a subset of set B? Well, the answer is yes, because set A has the colors red, blue, and yellow, and set B also contains the colors red, blue, and yellow, just a few extra colors. So A is a subset of B. Is A proper subset of B? So what I'm going to do is look at set A and look at set B. As long as all the elements of A are also in B, which that's the case because I highlighted all the ones in A and they're also in B, and does set A equal set B? No, because they don't have the same elements. Set B has orange, green, and violet in addition to red, yellow, and blue. So since set A doesn't equal set B, and set A, the elements of set A are also in set B, then A is a proper subset of B. Remember that you can pause this lecture at any time if you need to slow down or you need to rewatch something and also take notes. What I would like you to do right now is provide an example of two sets in which one is a subset of the other but is not a proper subset. So you may pause your video and try to come up with an example and unpause when you're ready. There's two important notes here. Every set is a subset of itself, but no set is a proper subset of itself. So in order to provide an answer to the example I asked you to think about, if we think about this, if you have a set, let's say set A is 1, 2, and 3, every set is also a subset of itself. So a subset of set A would also be 1, 2, and 3. But no set is a proper subset of itself. So here, A is a subset of itself, but A is not a proper subset of itself. And the reason is because in order for them to be proper subsets, remember that set A can't equal set B. And in this case, the two sets would be equal to each other because they would have the same elements. Another important note is that the empty set is a subset of every set, including itself. So that's important to remember. If you take any set and you were to list the subsets, you would always want to include the empty set as one of them. So if I take set A and I was to write the subsets of set A, you could have 1, 2, 3. You could also just have 1 and 2. You could look at 2 and 3. You could look at 1, 2, and 3, since every set is a subset of itself, and then also the empty set. And then I'm missing 1, so 1 and 3 also. There should be 8. Okay, in the next set of examples, we're going to determine if the following are true or false. So in the first example, is 3 an element of the set 3, 4, and 5? So remember, an element just means a member of, right? That means element, which means member of. So is 3 a member of the set 3, 4, 5? The answer is yes. That would be true. In the next example, is set 3 an element of the set 3, 4, and 5? This would be false because this represents a set, not an element in this case. In the next example, is set 3 an element of the set of set 3, set 4, and set 5? I can actually find this element within this set, so that is true. It is a member of the set. In the next example, is set 3 a subset of 3, 4, and 5? Yes, it is. I can pull just the 3 out of that larger set. That is true. In the next example, is 3 a subset of 3, 4, and 5? The answer is false. It's missing the braces around the 3. 3 is an element of set 3, 4, 5, not a subset. And the last example is the empty set, a subset of 3, 4, 5. That is, of course, true, since the empty set is always a subset of every set. how do we determine the number of subsets? So if you'll recall, when I was just doing this problem here, I counted and said there should be 8 subsets if I look at a set that has 3 elements in it. Okay, how did I know that off the top of my head? Well, there's actually a formula or a pattern that can help you determine the number of distinct subsets of a finite set A. So remember, distinct just means different. So if I was to look at a set, let's start with the empty set. The empty set, remember, is a subset of itself. So a subset of the empty set is the empty set. If I was to look at a set with one number in it, how many subsets are there? Well, you'd want to have the empty set, and also every set is a subset of itself. So 1 would be a subset of itself. If I had a set with 2 numbers in it, how many subsets would I have? You could have the empty set. You could have just the number 1, just the number 2, or every set is a subset of itself. So if you look, there's a pattern. When I have nothing in the set, if it's an empty set, there's 1 subset. When I have 1 element in the set, there's 2 subsets. When I have 2 elements in the set, there's 4 subsets. And if I was to keep going on, I would notice that this is a pattern of 2 to the 0, which is 1, 2 to the first, which is 2, 2 to the second, which is 4, all the way down to 2 to the n. And n is just the number of elements in set A, or whatever set it is. So if I want to figure out the number of distinct subsets of a finite set A, we're just going to take 2 and raise it to the nth power. N is the number of elements in set A. Since every set is a subset of itself, but no set is a proper subset of itself, right? Because you would have 2 sets that are equal, and they can't be equal if they're a proper subset. Thus, the number of proper subsets will always be 1 less than the number of subsets that can be made from any given set. So if I want to figure out the number of proper subsets, it's just going to be 2 to the n minus 1. It's always 1 less. So for example, if I'm given the set here, set A is the elements are S, L, E, and D. If I want to determine how many distinct subsets there are for A, I'm just going to take 2 and raise it to the number of elements in the set. So there's 4 elements in the set, so this is going to just be 2 to the 4th, or 16. So there's actually 16 subsets for A. I can list all of them. So what are the distinct subsets for the set A? So I'm going to have the actual set itself is a subset, and then I'm going to work on 3 letters at a time, and I'm just going to match the letters together with no repeats. So I would start out with like maybe SLE as a subset, and then maybe I'll do SLD, and then that's it for the S and the L's, and then I have to move to SEL. Whoops, sorry, that one's used. SED. Remember, I went distinct, right? So I couldn't use SEL because in that first subset I put SLE. You would also have LED. Okay, and that's it for the 3s. And then I could do 2 letters at a time. So S and L could be a subset. And then S and E. And then S and D. And then I could do L and E, and L and D, and I could also do E and D, and then I could do each of the letters. So S, L, E, and D, and then don't forget the empty set. So if you count, there should be 16 subsets for set A. and they're all distinct, so they're different. So how many proper subsets? Remember, the number of proper subsets is always one less than the number of distinct subsets. So to find the number of proper subsets, I'm just going to do 2 to the n minus 1. So we already know that we've got 2 to the 4th. We're just going to subtract 1. So 2 to the 4th is 16 minus 1 gives me 15. So there's 15 distinct, there's 15 proper subsets of set A. That ends the lecture for 2.2. Again, remember, you can always go back and rewatch things. If you have any questions, please don't hesitate to contact me. There's also tutoring at the Learning Support at school, either virtually or in person. I hope you all have a great rest of your day. And again, let me know if you need anything at all. Okay, bye everyone.